All right, so trigonometric functions, and we'll be in particular looking at how to graphically show your cosec and your sec functions. We're not going to be looking at cot. The chances of that coming in the paper are just too low. And like sine, cos, tan, I'm assuming that you guys know by now, and by in A2 at least. Okay, so when you talk about sec, or let's start with cosec. In fact, when you talk about cosec, it's basically equals to 1 upon, but if it's cosec x, it's equals to 1 upon sine x, right? So first of all, if you draw your let's say your basic sine curve, this is 90, let's say this is 180, 270, and 360. Now if you look at it here, wherever sine is 0, 1 upon 0, well, that would be undefined, right? It's not supposed to touch it. That you would draw an asymptote. I'm not sure how to spell this. Asymptote IDK, so like whatever, you get the idea. That dotted vertical line which you're never going to touch. So wherever sine of x is 0, that would lead cosec of x to be 1 upon 0, which is undefined. So you draw an asymptote there. Sine of x is 0 here. Well, guess what? It's not going to be touching your y-axis then. Sine of x is 0 here. Well, it's not going to be touching this line either. And the same goes for here. Now, where sine of x is 1, because if you think about it, if sine of x is 1, then 1 upon 1 is just 1. So if sine of x is 1, then cosec will also be 1. It will coincide there. So that happens here. Now if you think about it, cosec, it comes down from a really high, infinitely high value where x is 0. You show that you don't show it ever touching the x, the y-axis, because it's going to go all the way up to infinity, all the way up to a really high value. Comes down, it touches this, and the reason it has to go up back again is because it has to go back to that really high value, and that's half of your curve. Same thing happens here. So the blue, what I've drawn in blue is basically the curve for cosec x. So pretty simple. Let's see if we can look at some more difficult examples of this. All right, so let's try to complicate things a bit. So y is equals to 2 cosec x upon 2. So there are two things going on at the same time. I've divided x by 2, and I've also multiplied cosec x upon 2 by 2. Now, if you want to write this in terms of sine, this will really give you 2 upon sine x upon 2. However, this isn't very useful because the 2 is just lying up there in the numerator. You're not getting a complete value of sine in the denominator, which you can draw and then compare, right? So I can rearrange this to be 1 upon half sine x upon 2. So I get this one complete value of sine in the denominator. Obviously, a half of something in the denominator can simply be flipped to the numerator. So 1 upon half is the same as writing 2, right? So I haven't really made any difference or any impact on the actual equation. That still remains the same. Now let's try to draw this one. Let's try to draw it just for sine initially. So if it's sine x upon 2, that means it'll make one, I believe, so like one curve, well, it'll make half a curve in 360, so one curve in 720, right? So if you have let's say 180, 360, whatever that comes between 720 and what's like 180 plus 360, like that'll be 40, 400, 540, I believe, right? And this would go something like, if it's x upon 2, it'll form half a curve in 360. So this is your half a curve, and the rest of the half will be formed here. Let's use the bad handwriting. And the points are like 180. This is like 180 and 0.5. Again, remember, it's not going to go all the way up to 1 here because it's half sine x. So even here, your y value at least would still be 0.5. Now let's do the same thing we did above. Wherever this particular value is 0, you have to draw an asymptote because it can't touch that. Because the graph for cos can't touch that, rather. So here you have your asymptotes. Now, if you look at it, so where if you look at 180, for example, this value here, like this value here at 180 and 540 is giving you 0.5, right? We can read that off the graph. Let's look at it here. This is 0.5. So this is 1 upon 0.5 is what? Is 2. So your plotting at 180 should be 2. And like at obviously at 540 it's giving you minus 0.5. So here it should be minus 2. This is 2. This is minus 2. And then you do the rest. Rest has no change. It comes down from that asymptote at a very high value. It touches 2, and in this case it touches minus 2. And understand this, so these are like so this and this together gives you your one complete cycle. You have to be a little clear about that. And I believe let's just do one more case of cosec just to really ensure that this is clear. All right, so let's try to put a twist on this as well. So let's say y is equals to half cosec. Cosec x would become too easy. Let's just do 2x. All right. How can you say this in terms of sine? That is 1 upon 2 is already in your denominator. So 2 sine 2x, which is what we want. We want this thing to really bunch together, just 1 upon that. So it becomes easier for us to then compare with 2x, which is what we want. Okay, so if you draw just of this, if it is 2x, remember it's going to make 2 cycles in 360 degrees, which means one cycle will last 180 degrees. So let's just draw this from 0 to 180 just to make life easier. So like this is 180, this is 90, this is 45, this is what? I believe it's 135. My mental math is very weak. Anyhow, so your sine curve goes something like this, right? And understand that this point is 2 because of this. This point is again minus 2, right? It's going to make 2 cycles in 360 degrees or 1 cycle in 180 degrees because of this 2 right here. If you recall your AS math, and I've just drawn it for 0 to 180 degrees. Now you do the same thing that you did before. Wherever this is 0, you have to draw an asymptote. So asymptotes. Now, if you think about it, at 45 degrees, what are you getting? At 45 degrees, you have 1 upon 2, right? This value that sine is giving you is 2. So your cosec would be 0.5, half. So if this is 1, this is 0.5. Somewhere here is where you want to be plotting your the point for your cosec. Same for something like this, because at 135 degrees, your 2 sine 2x is giving you minus 2. So that's 1 upon minus 2. That is minus half. So you get something like this. This is one complete cycle. And that's it for cosec. Let's move on to sec. I'll only do the one case of sec because, I mean, if you're clear with cosec, you should be getting sec as well. Not really that much of a difference. So let's just do sec x, nice and easy. That is 1 upon cos x. So let's first draw it. I'm going to be doing this from 0 to 360 because that'll give me 1 cycle. So let's just draw your cos x curve. What was your cos x? So like this will you should start at 1 to go something, I believe something around the lines of here. Well, that's a pretty badly drawn curve. Let me try again. Okay, let's do this again. Does this comes back? Well, yeah, I think you get the idea. It's not supposed to be as sharp here. It's still supposed to be a curve rather than a V, but I think you guys get the idea. So this is 1, this is -1, and again, obviously this is 1 again. So the same thing still applies, which is why I'm just doing one case of this. So wherever this is 0, you just draw an asymptote, right? Now think of it, what happens when cosec x is 1? Where cosec x is 1, that is 1 upon 1 giving you 1, right? So that's where the points coincide. So where cosec x is 1, sec x should also be 1 because of 1 upon 1. So this is the point for, let's say, sec x. In fact, let's use a different color. Let's use blue. So this is the point of sec x where it's 1. Where cosec x is -1, 1 upon -1 gives you -1. So sec x should also be -1, should also be 1. Now, form something of this sort. It comes down from a really high value. I mean, it starts from 1 and goes up, like kind of supposed to go up theoretically all the way up to infinity. So it's just going to go up and do that thing we did with our cosec x. With this, it's very similar to your cosec x. This does this because of the because of the asymptotes. And here again, it just goes up because the idea here is you have your asymptote here, so it's kind of like coming down from a really high value, a really infinitely large value, giving you your y is equal to sec x. And literally the same things apply if you try to mess around with sec x the way you did with cosec x, making it 2x, making it 2 cosec half x, all of that type of stuff. All of those the same logic applies to sec x, which is why I'm not going to look at it because it's really the same thing. And that's it for your graphs for P3.